Learn SQL for Analytics. Vlad is a data engineer, and in this course he covers both the theory and the practice so you can confidently solve hard SQL challenges on your own. No previous experience required, and you'll do everything in your browser using BigQuery.
Hi everyone, my name is Vlad and I'm a data engineer. Welcome to Intuitive SQL for Analytics. This here is the main webpage for the course. You will find it in the video description, and this will get updated over time with links and resources, so be sure to bookmark it. Now, the goal of this course is to quickly enable you to use SQL to analyze and manipulate data. This is arguably the most important use case for SQL. And the practical objective is that by the end of this course, you should be able to confidently solve hard SQL problems of the kind that are suggested during data interviews. The course assumes no previous knowledge of SQL or programming, although it will be helpful if you've worked with spreadsheets such as Microsoft Excel or Google Sheets, because there's a lot of analogies between manipulating data in spreadsheets and doing it in SQL. And I also like to use spreadsheets to explain SQL concepts. Now, there are two parts to this course, theory and practice. The theory part is a series of short and sweet explainers about the fundamental concepts in SQL. And for this part, we will use Google BigQuery. BigQuery, which you can see here, is a Google service that allows you to upload your own data and run SQL on top of it. So in the course, I will teach you how to do that and how to do it for free. You won't have to spend anything. And then we will load our data and we will run SQL code. And besides this, there will be drawings, and we will also be working with spreadsheets and anything it takes to make the SQL concepts as simple and understandable as possible. The practice part involves doing SQL exercises, and for this purpose I recommend this website, PostgreSQL Exercises. This is a free and open source website where you will find plenty of exercises and you will be able to run SQL code to solve these exercises, check your answer, and then see a suggested way to do it. So I will encourage you to go here and attempt to solve these exercises on your own. However, I have also solved 42 of these exercises, the most important ones, and I have filmed explainers where I solve the exercise, break it apart, and then connect it to the concepts of the course. So after you've attempted the exercise, you will be able to see me solving it and connect it to the rest of the course. So how should you take this course? There are actually many ways to do it, and you're free to choose the one that works best. If you are a total beginner, I recommend doing the following. You should watch the theory lectures and try to understand everything. And then once you are ready, you should attempt to do the exercises on your own on the exercise website that I've shown you here. And if you get stuck or after you're done, you can watch how I solved the exercise. But like I said, this is just a suggestion, and you can combine theory and practice as you wish. And for example, a more aggressive way of doing this course would be to jump straight into the exercises and try to do them. And every time that you are stuck, you can actually go to my video and see how I solved the exercise. And then if you struggle to understand the solution, that means that maybe there's a theoretical gap, and then you can go to the theory and see how the fundamental concepts work. So feel free to experiment and find the way that works best for you. Now, let us take a quick look at the syllabus for the course. So getting started, this is a super short explainer on what SQL actually is. And then I teach you how to set up BigQuery, the Google service where we will load our data and run SQL for the theory part. The second chapter, writing your first query. So here I explain to you how BigQuery works and how you can use it, and how you are able to take your own data and load it in BigQuery so you can run SQL on top of it. And at the end of it, we finally run our first SQL query. Chapter 3 is about exploring some essential SQL concepts. So this is a short explainer of how data is organized in SQL, how the SQL statement works, meaning how we write code in SQL, and here is actually the most important concept of the whole course, the order of SQL operations. This is something that is not usually taught properly and a lot of beginners miss, and this causes a lot of trouble when you're trying to work with SQL. So once you learn this from the start, you will be empowered to progress much faster in your SQL knowledge. And then finally, we get into the meat of the course. This is where we learn all the different components in SQL, how they work and how to combine them together. So this happens in a few phases. In the first phase, we look at the basic components of SQL. So these are, there's a few of them. There's select and from. There's learning how to transform columns, the where filter, the distinct, union, order by limit. And then finally, we see how to do simple aggregations. At the end of this part, you will be empowered to do the first batch of exercises. Don't worry about the fact that there's no links yet. I will add them, but this is basically involves going to this PostgreSQL exercises website and going here and doing this first batch of exercises. And like I said before, after you've done the exercises, you can watch the video of me also solving them and breaking them down. Next, we take a look at complex queries, and this involves learning about subqueries and common table expressions. And then we look at joining tables. So here is where we understand how SQL tables are connected with each other and how we can use different types of joins to bring them together. And then you are ready for the second batch of exercises, which are those that involve joins and subqueries. And here there are 8 exercises. The next step is learning about aggregations in SQL. So this involves the group by, the having and window functions. And then finally, you are ready for the final batch of exercises, which actually bring together all the concepts that we've learned in this course. And these are 22 exercises. And like before, for each exercise, you have a video from me solving it and breaking it apart. And then finally, we have the conclusion. In the conclusion, we see how we can put all of this knowledge together, and then we take a look at how to use this knowledge to actually go out there and solve SQL challenges, such as the ones that are done in data interviews. And then here you'll find all the resources that are connected to the course. So you have the files with our data, you have the link to the spreadsheet that we will use, the exercises and all the drawings that we will do. This will definitely evolve over time as the course evolves, so bookmark this page and keep an eye on it. That was all you needed to know to get started, so I will see you in the course. If you are working with SQL or you are planning to work with SQL, you're certainly in great company. In the 2023 Developer Survey by Stack Overflow, there is a ranking of the most popular technologies out there. If we look at professional developers, where we have almost 70,000 responses, we can see that SQL is ranked as the 3rd most popular technology. SQL is certainly one of the most in-demand skills out there, not just for developers, but for anyone who works with data in any capacity. And in this course, I'm going to help you learn SQL the way I wish I would have learned it when I started out on my journey. Since this is a practical course, we won't go too deep into the theory. All you need to know for our purposes is that SQL is a language for working with data. Like most languages, SQL has several dialects. You may have heard of PostgreSQL or MySQL, for example. You don't need to worry about these dialects because they're all very similar. So if you learn SQL in any one of the dialects, you'll do well on all the others. In this course, we will be working with BigQuery, and thus we will write SQL in the Google SQL dialect. Here is the documentation for Google BigQuery, the service that we will use to write SQL code in this course. You can see that BigQuery uses Google SQL, a dialect of SQL which is ANSI compliant. ANSI compliant means that Google SQL respects the generally recognized standard for creating SQL dialects, and so it is highly compatible with all other common SQL dialects. As you can read here, Google SQL supports many types of statements, and statements are the building blocks that we use in order to get work done with SQL. And there are several types of statements listed here. For example, query statements allow us to retrieve and analyze and transform data. Data definition language statements allow us to create and modify database objects such as tables and views. Whereas data manipulation language statements allows us to update and insert and delete data from our tables. Now in this course, we focus exclusively on query statements, statements that allow us to retrieve and process data. And the reason for this is that if you're going to start working with BigQuery, you will most likely start working with this family of statements. Furthermore, query statements are in a sense the foundation for all other families of statements. So if you understand query statements, you'll have no trouble learning the others on your own. Why did I pick BigQuery for this course? I believe that the best way to learn is to load your own data and follow questions that interest you and play around with your own projects. And BigQuery is a great tool to do just that. First of all, it is free, at least for the purposes of learning and for the purposes of this course. It has a great interface that will give you really good insights into your data. And most importantly, it is really easy to get started. You don't have to install anything on your computer. You don't have to deal with complex software. You just sign up for Google Cloud and you're ready to go. And finally, as you will see next, BigQuery gives you many ways to load your own data easily and quickly and get started writing SQL right away. I will now show you how you can sign up for Google Cloud and get started with BigQuery. So it all starts with this link, which I will share in the resources, and this is the homepage of Google Cloud. And if you don't have an account with Google Cloud, you can go here and select Sign In. And here you need to sign in with your Google account, which you probably have, but if you don't, you can go here and select Create Account. So I have now signed in with my Google account, which you can see here in the upper right corner, and now I get a button that says Start Free. So I'm going to click that, and now I get taken to this page, and on the right you see that the first time you sign up for Google Cloud, you get $300 of free credits so that you can try the services, and that's pretty neat. And here I have to enter some extra information about myself, so I will keep it as is and agree to the terms of service and continue. Finally, I need to do the payment information verification. So unfortunately, this is something I need to do even though I'm not going to be charged for the services, and this is for Google to be able to verify my identity. So I will pick individual as account type and insert my address. And finally, I need to add a payment method. And again, I need to do this even though I'm not going to pay. I will actually not do it here because I don't intend to sign up, but after you are done, you can click start my free trial and then you should be good to go. Now, your interface may look a bit different, but essentially, after you've signed up for Google Cloud, you will need to create a project. And the project is a tool that organizes all your work in Google Cloud. And essentially, every work that you do in Google Cloud has to happen inside a specific project. Now, as you can see here, there is a limited quota of projects, but that's not an issue because we will only need one project to work in this course. And of course, creating a new project is totally free. So I will go ahead and give it a name. And I don't need any organization, and I will simply click on Create. Once that's done, I can go back to the home page for Google Cloud, and here, as you can see, I can select a project, and here I find the project that I have created before, and once I select it, the rest of the page won't change, but you will see the name of the project in the upper bar here. Now, although I've created this project as an example for you, for the rest of the course, you will see me working within this other project, which was the one that I had originally. Now, I will show you how you can avoid paying for Google Cloud services if you don't want to. So from the home page, you have this search bar over here, and you can go here and write billing and click payment overview to go to the billing service. Now here on the left, you will see your billing account, which could be called like this or have another name. And clicking here, I can go to manage billing accounts. Now here I can go to my projects tab and I see a list of all of my projects in Google Cloud. And a project might or might not be connected to a billing account. If a project is not connected to a billing account, then Google won't be able to charge you for this project. Although keep in mind that if you link your project with a billing account and then you incur some expenses, if you then remove the billing account, you will still owe Google Cloud for those expenses. So what I can do here is go to my projects, and on actions, I can select disable billing in case I have a billing account connected. Now, while this is probably the surest way to avoid incurring any charges, you will see that you will be severely limited in what you can do in your project if that project is not linked to any billing account. However, you should still be able to do most of what you need to do in BigQuery, at least for this course. And we can get more insight into how that works by going to the BigQuery pricing table. So this page gives us an overview of how pricing works for BigQuery. I will not analyze this in depth, but what you need to know is that when you work with BigQuery, you can fundamentally be charged for two things. One is compute pricing, and this basically means all the data that BigQuery scans in order to return the results that you need when you write your query. And then you have storage pricing, which is what you pay in order to store your data inside BigQuery. Now, if I click on compute pricing, I will go to the pricing table, and here you can select the region that most reflects where you are located. and I have selected Europe here. And as you can see, you are charged $6.25 at the time of this video for scanning a terabyte of data. However, the first terabyte per month is free. So every month you can write queries that scan 1 terabyte of data and not pay for them. And as you will see more in detail, this is more than enough for what we will be doing in this course, and also for what you'll be doing on your own in order to experiment with SQL. And if I go back to the top of the page and then click on storage pricing, you can see here that again, you can select your region and see several pricing units, but here you can see that the first 10 gigabytes of storage per month is free. So you can put up to 10 gigabytes of data in BigQuery and you won't need a billing account, you won't pay for storage, and this is more than enough for our needs in order to learn SQL. In short, BigQuery gives us a pretty generous free allowance for us to load data and play with it, and we should be fine. However, I do urge you to come back to this page and read it again, because things may have changed since I recorded this video. To summarize, go to the billing service, check out your billing account, and you have the option to decouple your project from the billing account to avoid incurring any charges, and you should still be able to use BigQuery. But as a disclaimer, I cannot guarantee that things will work just the same at the time that you are watching this video. So be sure to check the documentation or maybe discuss with Google Cloud support to avoid incurring any unexpected expenses. Please do your research and be careful in your usage of these services. For this course, I have created an imaginary dataset with the help of ChatGPT. The dataset is about a group of fantasy characters, as well as their items and inventories. I then proceeded to load this data into BigQuery, which is our SQL system. I also loaded it into Google Sheets, which is a spreadsheet system similar to Microsoft Excel. This will allow me to manipulate the data visually and help you develop a strong intuition about SQL operations. I'm going to link a separate video which explains how you can also use ChatGPT to generate imaginary data according to your needs, and then load this data in Google Sheets or BigQuery. I will also link the files for this data in the description, which you can use to reproduce this data on your side. Next, I will show you how we can load the data for this course into BigQuery. So I'm on the homepage of Google Cloud and I have a search bar up here, and I can write BigQuery and select it from here, and this will take me to the BigQuery page. Now, there is a panel on the left side that appears here if I hover, or it could be fixed. And this is showing you several tools that you can use within BigQuery. And you can see that we are in the SQL workspace, and this is actually the only tool that we will need for this course. So if you're seeing this panel on the left, I recommend going to this arrow in the upper left corner and clicking it so you can disable it and make more room for yourself. Now, I want to draw your attention to the Explorer tab, which shows us where our data is and how it is organized. So I'm going to expand it here. Now, data in BigQuery and in SQL in general exists in the form of tables. And a table looks just like this. As you can see here, the customers table. It is a collection of rows and columns, and it is quite similar to a spreadsheet. So this will be familiar to you if you've ever worked with Microsoft Excel or Google Sheets or any spreadsheet program. So your data is actually living in a table, and you could have as many tables as you need in BigQuery. There could be quite a lot of them. So in order to organize our tables, we use datasets. For example, in this case, my data is a dataset which contains the table customers and employee data. And a dataset is just that. It's a collection of tables, and it's similar to how a folder works in a file system. It is like a folder for tables. Finally, in BigQuery, each dataset belongs to a project. So you can see here that we have two datasets, SQL Course and My Data, and they both belong to this project, Idyllic Physics and so on. And this is actually the ID of my project. This is the ID of the project that I'm working in right now. The reason the Explorer tab shows the project as well is that in BigQuery, I'm not limited to working with data that lives in my project. I could also, from within my project, query data that lives in another project. For example, the BigQuery public data is a project that is not mine, but it's actually a public project by BigQuery. And if I expand this, you will see that it contains a collection of several datasets, which are in themselves collections of tables, and I would be able to query these tables as well. But you don't need to worry about that now, because in this course we will only focus on our own data that lives in our own project. So this, in short, is how data is organized in BigQuery. Now, for the purpose of this course, I recommend creating a new dataset so that our tables can be neatly organized. And to do that, I can click the three dots next to the project ID over here and select Create Dataset. And here I need to pick a name for the dataset. So I will call this Fantasy, and I suggest you use the same name, because if you do, then the code that I share with you will work immediately. Then, as for the location, you can select multi-region and choose the region that is closest to you. And finally, click on Create Dataset. So now the dataset Fantasy has been created, and if I try to expand it here, I will see that it is empty because I haven't loaded any data yet. The next step is to load our tables. So I assume that you have downloaded the zip file with the tables and extracted it on your local computer, and then we can select the action point here next to the Fantasy dataset and select Create Table. Now, as a source, I will select Upload, and here I will click on Browse and access the files that I have downloaded. And I will select the first table here, which is the characters table. The file format is CSV, so Google has already understood that. And scrolling down here, I need to choose a name for my table. So I will call it just like the file, which is characters. And very important, under schema, I need to select auto detect. And we will see what this means in a bit. But basically this is all we need. So now I will select Create Table. And now you will see that the characters table has appeared under the Fantasy dataset. And if I click on the table and then go on preview, I should be able to see my data. I will now do the same for the other two tables. So again, create table, source is upload, file is inventory, repeat the name, and select auto detect. And I have done the same with the third table. So at the end of this exercise, the fantasy dataset should have 3 tables, and you can select them and go on preview to make sure that the data looks as expected. Now our data is fully loaded and we are ready to start querying it within BigQuery. Now let's take a look at how the BigQuery interface works. So on the left here, you can see the Explorer, which shows all the data that I have access to. And so to get a table in BigQuery, first of all, you open the name of the project, and then you look at the datasets that are available within this project. You open a dataset, and finally you see a table such as characters. And if I click now on characters, I will open the table view. Now in the table view, I will find a lot of important information about my table in these tabs over here. So let's look at the first tab, Schema. The Schema tab shows me the structure of my table, which, as we shall see, is very important. And the schema is defined essentially by 2 things: the name of each column in my table and the data type of each column. So here we see that the characters table contains a few columns such as ID, name, guild, class, and so on. And these columns have different data types. For example, ID is an integer, which means that it contains natural numbers, whereas name is string, which means that it contains text. And as we shall see, the schema is very important because it defines what you can do with the table. And next we have the Details tab, which contains a few things. First of all is the table ID, and this ID represents the full address of the table. And this address is made up of 3 components. First of all, you have the ID of the project, which is, as you can see, the project in which I'm working, and is the same that you see here on the left in the Explorer tab. The next component is the dataset that contains the table, and again you see it in the Explorer tab. And finally you have the name of the table. This address is important because it's what we use to reference the table, and it's what we use to get data from this table. And then we see a few more things about the table, such as when it was created, when it was last modified. And here we can see the storage information. So we can see here that this table has 15 rows, and on the disk it occupies approximately 1 kilobyte. If you work extensively with BigQuery, this information will be important for 2 reasons. Number 1, it defines how much you are paying every month to store this table. And number 2, it defines how much you would pay for a query that scans all the data in this table. And as we have seen in the lecture on BigQuery pricing, these are the 2 determinants of BigQuery costs. However, for the purpose of this course, you don't need to worry about this because the tables we are working with are so small that they won't put a dent in your free monthly allowance for using BigQuery. Next, we have the Preview tab, which is really cool to get a sense of the data, and this basically shows you a graphical representation of your table, and as you will notice, it looks very similar to a spreadsheet. So you can see our columns, the same ones that we saw in the Schema tab: ID, name, guild, and so on. And as you remember, we saw that ID is an integer column, so it can only contain numbers. Name is a text column. And then you see that this table has 15 rows, and because it's such a small table, all of it fits into this graphical representation. But in the real world, you may have tables with millions of rows, and in this case, the preview will show you only a small portion of that table, but still enough to get a good sense of the data. Now, there are a few more tabs in the table view. We have lineage, data profile, data quality, but I'm not going to look at them now because they are like advanced features in BigQuery and you won't need them in this course. Instead, I will run a very basic query on this table. And this is not for the purpose of understanding the query, that will come soon. It is for the purpose of showing you what the interface looks like after you run a query. So I have a very basic query here that we run on my table, and you can see that the interface is telling me how much data this query will process. And this is important because this is the main determinant of cost in BigQuery. Every query scans a certain amount of data and you have to pay for that. But as we saw in the lecture of BigQuery pricing, this table is so small that you could run 1 million or more of these queries and not exhaust your monthly allowance. So if you see 1 kilobyte, you don't have to worry about that. So now I will click run and my query will execute. And here I get the query results view. This is the view that appears after you have successfully run a query. So we have a few tabs here. And the first tab that you see is results. And this shows you graphically the table that was returned by your query. So as we shall see, every query in SQL runs on a table and returns a table. And just like the preview tab showed you a graphical view of your table, the results tab shows you a graphical view of the table that your query has returned. And this is really the only tab in the query results view that you will need on this course. The other ones show different features or more advanced features that we won't look at, but feel free to explore them on your own if you are curious. But what's also important in this view is this button over here, Save Results, which you can use to export the result of your query towards several different destinations, such as Google Drive or local files on your computer in different formats, or another BigQuery table, a spreadsheet in Google Sheets, or even copying them to your clipboard so that you can paste them somewhere else. But we shall discuss this more in detail in the lecture on getting data in and out of BigQuery. Finally, if you click on this little keyboard icon up here, you can see a list of shortcuts that you can use in the BigQuery interface. And if you end up running a lot of queries and you want to be fast, this is a nice way to improve your experience with BigQuery. So be sure to check these out. We are finally ready to write our first query, and in the process we will keep exploring the fantastic BigQuery interface. So one way to get started would be to click this plus symbol over here so that we can open a new tab. Now, to write the query, the first thing I will do is to tell BigQuery where the data that I want lives. And to do that, I will use the from clause. So I will simply write from, and my data lives in the fantasy dataset and in the characters table. Next, I will tell SQL what data I actually want from this table. And the simplest thing to ask for is to get all the data. And I can do this by writing select star. Now my query is ready, and I can either click run up here, or I can press Command Enter on my Mac keyboard, and the query will run. And here I get a new tab which shows me the results. Now the results here are displayed as a table, just as we saw in the preview tab of the table, and I can get an idea of my results. And this is actually the whole table because this is what I asked for in the query. There are also other ways to see the results which are provided by BigQuery, such as JSON, which shows the same data but in a different format, but we're not going to be looking into that for this course. One cool option that the interface provides is if I click on this arrow right here in my tab, I can select split tab to right, and now I have a bit of less room in my interface, but I'm seeing the table on the left and the query on the right, so that I can look at the structure of the table while writing my query. For example, if I click on schema here, I could see which columns I am able to reference in my query, and that can be pretty handy. I could also click this toggle to close the Explorer tab temporarily if I don't need to look at those tables, so I can make a bit more room, or I can reactivate it when needed. I will now close this tab over here, go back to the characters table, and show you another way that I can write a query, which is to use this query command over here. So if I click here, I can select whether I want my query in a new tab or in a split tab. Let me say in new tab. And now BigQuery has helpfully written a template for a query that I can easily modify in order to get my data. And to break down this template, as you can see, we have the select clause that we used before, we have the from clause, and then we have a new one called limit. Now the from clause is doing the same job as before. It is telling BigQuery where we want to get our data. But you will notice that the address looks a bit different from the one that I had used. Specifically, I used the address fantasy.characters. So what's happening here is that fantasy.characters is a useful shorthand for the actual address of the table. And what we see here that BigQuery provided is the actual full address of the table, or in other words, it is the table ID. And as you remember, the table ID indicates the project ID, the dataset name, and the table name. And importantly, this ID is usually enclosed by backticks, which are a quite specific character. Long story short, if you want to be 100% sure, you can use the full address of the table and BigQuery will provide it for you. But if you are working within the same project where the data lives, so you don't need to reference the project, you can also use this shorthand here to make writing the address easier. And in this course, I will use these two ways to reference a table interchangeably. I will now keep the address that BigQuery provided. Now the limit statement, as we will see, is simply limiting the number of rows that will be returned by this query. No more than 1000 rows will be returned. And next to the select, we have to say what data we want to get from this table. And like before, I can write star, and now my query will be complete. Before we run our query, I want to draw your attention to this message over here. This query will process 1 kilobyte when run. So this is very important because here BigQuery is telling you how much data will be scanned in order to give you the results of this query. In this case, we are returning all the data in the table. Therefore, all of the table will be scanned. And actually, limit does not have any influence on that. It doesn't reduce how much data is scanned. So this query will scan 1 kilobyte of data. And the amount of data that is scanned by the query is the primary determinant of BigQuery costs. Now, as you remember, we are able to scan up to 1 terabyte of data each month within the Sandbox program. And if we wanted to scan more data, then we would have to pay. So the question is, how many of these queries could we run before running out of our free allowance? Well, to answer that, we could check how many kilobytes are in a terabyte. And if you Google this, the conversion says it's 1 to multiplied by 10 to the power of 9, which ends up being 1 billion. Therefore, we can run 1 billion of these queries each month before running out of our allowance. Now you understand why I've told you that as long as you work with small tables, you won't really run out of your allowance and you don't really have to worry about costs. However, here's an example of a query that will scan a large amount of data. And what I've done here is I've taken one of the public tables provided by BigQuery, which I've seen to be quite large, and I have told BigQuery to get me all the data for this table. And as you can see here, BigQuery says that 120 gigabytes of data will be processed once this query runs. Now, you would need about 8 of these queries to get over your free allowance. And if you had billing connected to BigQuery, you could also be charged money for any extra work that you do. So be very careful about this. And if you work with large tables, always check this message over here before running the query. And remember, you won't actually be charged until you actually hit run on the query. And there you have it. We learned how the BigQuery interface works and wrote our first SQL query. It is important that we understand how data is organized in SQL. So we've already seen a preview of the characters table, and we've said that this is quite similar to how you would see data in a spreadsheet. Namely, you have a table, which is a collection of rows and columns, and then in this case, on every row, you have a character, and for every character, you have a number of information points such as their ID, their name, their class, level, and so on. The first fundamental difference with a spreadsheet is that if I want to have some data in a spreadsheet, I can just open a new one and insert some data in here, right? So ID, level, name, and so on. And then I could say that I have a character ID 1 who is level 10 and his name is Gandalf. And this looks like the data I have in SQL. And I could add some more data as well. A new character, ID 2, level 5, and the name is Frodo. Now I will save this spreadsheet, and then some days later, someone else comes in, let's say a colleague, and they want to add some new data, and they say, oh, ID is unknown, level is 20.3, and the name here, and then I also want to show their class, so I will just add another column here and call this mage. Now, spreadsheets are of course extremely flexible because you can always add another column and write in more cells, and you can basically write wherever you want. But this flexibility comes at a price, because the more additions we make to this to the data model that is represented here, the more complex it will get with time, and the more likely it will be that we make confusions or mistakes, which is what actually happens in real life when people work with spreadsheets. SQL takes a different approach. In SQL, before we insert any actual data, we have to agree on the data model that we're going to use. And the data model is essentially defined by two elements: the name of our columns and the data type that each column will contain. For example, we can agree that we will use 3 columns in our table: ID, level, and name. And then we can agree that ID will be an integer, meaning that it will contain whole numbers. Level will be an integer as well, and name will be a string, meaning that it contains text. Now that we've agreed on this structure, we can start inserting data on the table, and we have a guarantee that this structure will not change with time. And so any queries that we write on top of this table, any sort of analysis that we create for this table will also be durable in time, because it will have the guarantee that the data model of the table will not change. And then if someone else comes in and wants to insert this row, they will actually not be allowed to. First of all, because they are trying to insert text into an integer column. And so they are violating the data type of the column, and they are not allowed to do that. In level, they are also violating the data type of the column, because this column only accepts whole numbers, and they're trying to put a floating point number in there. And then finally, they are also violating the column definition, because they're trying to add a column class that was not actually included in our data model and that we didn't agree on. So the most important difference between spreadsheets and SQL is that for each SQL table, you have a schema, and as we've seen before, the schema defines exactly which columns our table has and what is the data type of each column. So in this case, for the characters table, we have several columns, and here we can see their names, and then each column has a specific data types, and all the most important data types are actually represented here. Specifically, by integer, we mean a whole number, and by float, we mean a floating point number. String is a piece of text. Boolean is a value that is either true or false, and timestamp is a value that represents a specific point in time. All of this information, so the number of columns, the name of each column, and the type of each column, they constitute the schema of the table. And like we've said, the schema is assumed as a given when working in SQL, and it is assumed that it will not change over time. Now, in special circumstances, there are ways to alter the schema of a table, but it is generally assumed as a given when writing queries, and we shall do the same in this course. And why is it important to keep track of the data type? Why is it important to distinguish between integer, string, boolean? The simple answer is that the data type defines the type of operations that you can do to a column. For example, if you have an integer or a float, you can multiply the value by 2 or divide it and so on. If you have a string, you can turn that string to uppercase or lowercase. If you have a timestamp, you can subtract 30 days from that specific moment in time, and so on. So by looking at the data type, you can find out what type of work you can do with a column. The second fundamental difference from spreadsheets is that spreadsheets are usually disconnected, but SQL has a way to define connections between tables. So what we see here is a representation of our three tables, and for each table you can see the schema, meaning the list of columns and their types. But the extra information that we have here is the connection between the tables. So you can see that the inventory table is connected to the items table and also to the characters table. Moreover, the characters table is connected with itself. Now, we're not going to explore this in depth now because I don't want to add too much theory. We will see this in detail in the chapter on joins. But it is a fundamental difference from spreadsheets that SQL tables can be clearly connected with each other. And that's basically all you need to understand how data is organized in SQL for now. You create a table, and when creating that table, you define the schema. The schema is the list of columns and their names and their data types. You then insert data into these tables, and finally you have a way to define how the tables are connected with each other. I will now show you how SQL code is structured and give you the most important concept that you need to understand in order to succeed at SQL. Now this is a SQL statement. It is like a complete sentence in the SQL language. The statement defines where we want to get our data from and how we want to receive this data, including any processing that we want to apply to it. And once we have a statement, we can select run and it will give us our data. Now, the statement is made up of building blocks, which we call clauses. And in this statement, we have a clause for every line. So the clauses that we see here are select, from, where, group by, having, order, and limit. And clauses are really the building blocks that we assemble in order to build statements. What this course is about is understanding what each clause is and how it works, and then understanding how we can put together these clauses in order to write effective statements. Now, the first thing that you need to understand is that there is an order to writing these clauses. You have to write them in the correct order, and there is no flexibility there. If you write them in the wrong order, you will simply get an error. For example, if I were to take the where clause and put it below the group clause, you can see that I'm already getting an error here, which is a syntax error. But you don't have to worry about memorizing this now, because you will pick up this order as we learn each clause in turn. Now, the essential thing that you need to understand, and that slows down so many SQL learners, is that while we are forced by SQL to write clauses in this specific order, this is not actually the order in which the clauses are executed. If you've interacted with another programming language such as Python or JavaScript, you're used to the fact that each line of your program is executed in turn from top to bottom, generally speaking, and that is pretty transparent to understand. But this is not what is happening here in SQL. To give you a sense of the order in which these clauses are run, on a logical level, what SQL does is that first it reads the from, then it does the where, then the group by, then the having, then it does the select part. After the select part, it does the order by, and finally the limit. All of this just to show that the order in which operations are executed is not the same as the order in which they're written. In fact, we can distinguish three orders that pertain to SQL clauses, and this distinction is so important to help you master SQL. The first level is what we call the lexical order, and this is simply what I've just shown you. It's the order in which you have to write these clauses so that SQL can actually execute the statement and not throw you an error. Then there's the logical order, and this is the order in which the clauses are actually run logically in the background. And understanding this logical order is crucial for accelerating your learning of SQL. And finally, for the sake of completeness, I had to include the effective order here, because what happens in practice is that your statement is executed by a SQL engine, and that engine will usually try to take shortcuts and optimize things and save on processing power and memory. And so the actual order might be a bit different because the clauses might be moved around in the process of optimization. But like I said, I've only included it for the sake of completeness, and we're not going to worry about that level in this course. We are going to focus on mastering the lexical order and the logical order of SQL clauses. And to help you master the logical order of SQL clauses or SQL operations, I have created this schema. And this is the fundamental tool that you will use in this course. This schema, as you learn it progressively, will allow you to build a powerful mental model of SQL that will allow you to tackle even the most complex and tricky SQL problems. Now, what this schema shows you is all of the clauses that you will work with when writing SQL statements. So these are the building blocks that you will use in order to assemble your logic. And then the sequence in which they're shown is corresponding to the logical order in which they are actually executed. And there are three simple rules for you to understand this schema. The first rule is that operations are executed sequentially from left to right. The second rule is that each operation can only use data that was produced by operations that came before it. And the third rule is that each operation cannot know anything about data that is produced by operations that follow it. What this means in practice is that if you take any of these components, for example, the having component, you already know that having will have access to data that was produced by the operations that are to its left. So aggregations, group by, where, and from. However, having will have absolutely no idea of information that is produced by the operations that follow. For example, window or select or union, and so on. Of course, you don't have to worry about understanding this and memorizing it now, because we will tackle this gradually throughout the course. And throughout the course, we will go back to the schema again and again in order to make sense of the work we're doing and understand the typical errors and pitfall that happen when working with SQL. Now, you may be wondering why there are these two cases where you actually see two components stacked on top of each other, that being from and join, and then select and alias. These are actually components that are tightly coupled together, and they occur at the same place in the logical ordering, which is why I have stacked them like this. In this section, we tackle the basic components that you need to master in order to write simple but powerful SQL queries. And we are back here with our schema of the logical order of SQL operations, which is also our map for everything that we learn in this course. But as you can see, there is now some empty space in this schema because to help us manage the complexity, I have removed all of the components that we will not be tackling in this section. Let us now learn about from and select, which are really the two essential components that you need in order to write the simplest SQL queries. Going back now to our data, let's say that we wanted to retrieve all of the data from the characters table in the fantasy dataset. Now, when you have to write a SQL query, the first question you need to ask yourself is, where is the data that I need? Because the first thing that you have to do is to retrieve the data, which you can then process and display as needed. So in this case, it's pretty simple. We know that the data we want lives in the characters table. Once you've figured out where your data lives, you can write the from clause. So I always suggest starting queries with the from clause. And to get the table that we need, we can write the name of the dataset, followed by a dot, followed by the name of the table. And you can see that BigQuery has recognized the table here. So I have written the from clause and I have specified the address of the table, which is where the data lives. And now I can write the select clause. And in the select clause, I can specify which columns of the table I want to see. So if I click on the characters table here, it will open in a new tab in my panel. And as you remember, it shows me here the schema of the table. And the schema includes the list of all the columns. Now I can simply decide that I want to see the name and the guild. And so in the select statement here, I will write name and guild. And when I run this, I get the table with the two columns that I need. And one neat thing about this, I could write the columns in any order. It doesn't have to be the original order of the schema, and the result will show that order. And if I wanted to get all of the columns of the table, I could write them here one by one, or I could write star, which is a shorthand for saying, please give me all of the columns. So this is the corresponding data to our table in Google Sheets. And if you want to visualize select in your mind, you can imagine it as vertically selecting the parts of the table that you need. For example, if I were to write select guild and level, this would be equivalent to taking these two columns over here and selecting them. Let us now think of the logical order of these operations. So first comes the from, and then comes the select. And this makes logical sense, right? Because the first thing you need to do is to source the data. And later you can select the parts of the data that you need. In fact, if we look at our schema over here, from is the very first component in the logical order of operations, because the first thing that we need to do is to get our data. We have seen that the select clause allows us to get any columns from our table in any order. But the select clause has many other powers. So let's see what else we can do with it. One useful thing to know about SQL is that you can add comments in the code, and comments are parts of text which are not executed as code. They're just there for you to keep track of things or explain what you are doing. So I'm going to write a few comments now. And the way we do comments is by doing dash dash. And now I'm going to show you aliasing. Aliasing is simply renaming a column. So I could take the level column and say as character level, provided a new name. And after I run this, we can see that the name of the column has changed. Now, one thing that's important to understand as we now start transforming the data with our queries is that any sort of change that we apply, such as in this case, we change the name of the column, it only affects our results. It does not affect the original table that we are querying. So no matter what we do here moving forward, the actual table, fantasy characters, will not change. All that will change are the results that we get after running our query. And of course, there are ways to go back to fantasy characters and permanently change it, but that is outside the scope for us. And going back to our schema, you will see that alias has its own component and it happens at the same time as the select component. And this is important because, as we will see in a bit, that it's a common temptation to use these aliases, these labels that we give to columns, in the phases that precede this stage, which typically fails because, as our rules say, every component does not have access to data that is computed after it. So something that we will come back to. Now, another power of select that we want to show is constants. And constants is the ability of creating new columns which have a constant value. For example, let's say that I wanted to implement a versioning system for my characters. And I would say that right now, all the characters I have are version 1. But then in the future, every time I change a character, I will increase that version. And so that will allow me to keep track of changes. I can do that by simply writing 1 over here in the column definition. And when I run this, you will see that SQL has created a new column and it has put 1 for every row in that column. This is why we call it a constant column. So if I scroll down, all of it will be 1. And this column has a weird name because we haven't provided a name for it yet, but we already know how to do this. We can use the aliasing command to call it version. And here we go. So in short, when you write a column name in the select statement, SQL looks for that column in the table and gives you that column. But when instead you write a value, SQL creates a new column and puts that value in every row. The next thing that SQL allows me to do is calculations. So let me call the experience column here as well and get my data. Now, one thing I could do is to take experience and divide it by 100. So what we see here is a new column, which is the result of this calculation. Now, 100 is a constant value, right? So you can imagine in the background, SQL has created a new column and put 100 in every row, and then it has done the calculation between experience and that new column, and we get this result. And in short, we can do any sort of calculation we want, combining current columns and constants as will. For example, although this doesn't make any sense, I could take experience, add 100 to it, divide it by character level, and then multiply it by 2. And we see that we got an error. Can you understand why we got this error? Pause the video and think for a second. I am referring to my column as character level. But what is character level really? It is a label that I have assigned over here. Now, if we go back to our schema, we can see that select and alias happen at the same time. So this is the phase in which we assign our label, and this is also the phase in which we try to call our label. Now, if you look at our rules, this is not supposed to work because an operation can only use data produced by operations before it. And alias does not happen before select, it happens at the same time. In other words, this part over here, when we say character level, is attempting to use information that was produced right here when we assign the label. But because these parts happen at the same time, it's not aware of the label. All this to say that the logical order of operations matters, and that what we want here is to actually call it level, because that is the name of the column in the table. And now when I run this, I get a resulting number. And so going back to our original point, we are able to combine columns and constants with any sort of arithmetic operations. Another very powerful thing that SQL can do is to apply functions. And a function is a pre-packaged piece of logic that you can apply to our data. And it works like this. There is a function called sqrt, which stands for square root, which takes a number and computes the square root. So you call the function by name, and then you open round brackets. And in round brackets, you provide the argument. And the argument can be a constant, such as 16, or it can be a column, such as level. And when I run this, you can see that in this case, the square root of 16 is calculated as 4, and this creates a constant column. And then here, for each value of level, we have also computed the square root. There are many functions in SQL, and they vary according to the data type which you provide. As you remember, we said that knowing the data types of columns, such as distinguishing between numbers and text, is important because it allows us to know which operations we can apply. And so there are functions that work only on certain data types. For example, here we see square root, which only works on numbers, but we also have text functions or string functions which only work on text. One of them is upper. So if I take upper and provide guild as an argument, what do you expect will happen? We have created a new column where the guild is shown in all uppercase. So how can I remember which functions there are and how to use them? The short answer is I don't. There are many functions in SQL, and here in the documentation you can see a very long list of all the functions that you can use in BigQuery. And as we said, the functions vary according to the data that they can work on. So if you look here on the left, we have array functions, date functions, mathematical functions, numbering functions, time functions, and so on and so on. It is impossible to remember all of these functions, so all you need to know is how to look them up when you need them. For example, if I know I need to work with numbers, I could scroll down here and go to mathematical functions. And here I have a long list of all the mathematical functions, and I can see them all on the right. And I should be able to find the square root function that I have showed you. And here the description tells me what the function does, and it also provides some examples. To summarize, these are some of the most powerful things you can do with the select statement. Not only you can retrieve every column you need in any order, you can rename columns according to your needs. You can define constant columns with a value that you choose. You can combine columns and constant columns in all sorts of calculations. And you can apply functions to do more complex work. I definitely invite you to go ahead and put your own data in BigQuery as I've shown you, and then start playing around with select and see how you can transform your data with it. One thing worth knowing is that I can also write queries that only include select without the from part. That is, queries that do not reference a table. Let's see how that works. Now, after I write select, I clearly cannot reference any columns because there is no table, but I can still reference constants. For example, I could say hello, 1, and false. And if I run this, I get this result. So remember, in SQL, we always query tables and we always get back tables. In this case, we didn't reference any previous table. We've just created constants. So what we have here are 3 columns with constant values, and there is only 1 row in the resulting table. This is useful mainly to test stuff. So let's say I wanted to make sure that the square root function does what I expect it to do. So I could call it right here and look at the result. Let's use this capability to look into the order of arithmetic operations in SQL. So if I write an expression like this, would you be able to compute the final result? In order to do that, you should be able to figure out the order in which all these operations are done. And you might remember this from arithmetic in school because SQL applies the same order that is taught in school. And we could define the order as follows. First, you would execute any specific functions that take a number as target. And then you have multiplication and division. Then you have addition and subtraction. And finally, brackets go first. So you first execute things that are within brackets. So pause the video and apply these rules and see if you can figure out what this result will give us. Now let's do this operation and do it in stages like we were doing in school. So first of all, we want to worry about what's in the brackets, right? So I will now consider this bracket over here. And in this bracket, we have the multiplication and addition. Multiplication goes first. So first I will execute this, which will give me 4. And then I will have 3 plus 4 plus 1, which should give me 8. Next, I will copy the rest of the operation. And here I reach another bracket. To execute what is in these brackets, I need to first execute the function. So this is the power function. So it takes 2 and exponentiates it to the power of 2, which gives 4. And then 4 minus 2 will give me 2. And this is what we get. Now we can solve this line. And first of all, we need to execute multiplication and division in the order in which they occur. So the first operation that occurs here is 4 divided by 2, which is 2. And I will just copy this for clarity. 8 minus 2 times 2 divided by 2. The next operation that occurs now is 2 times 2, which is 4. So that will be 8 minus 4 divided by 2. And the next operation is 4 divided by 2, which is 2. So I will have 8 minus 2, and all of these will give me a 6. Now all of these are comments, and we only have one line of code here. And to see whether I was right, I just need to execute this code. And indeed, I get 6. So that's how you can use the select clause only to test your assumptions and your operations, and a short refresher on the order of arithmetic operations, which will be important for solving certain SQL problems. Let us now see how the where statement works. Now, looking at the characters table, I see that there is a field which is called isAlive, and this field is of type Boolean. That means that the value can be either true or false. So if I go to the preview here and scroll to the right, I can see that for some characters this is true and for others it is false. Now, let's say I only wanted to get those characters which are actually alive. And so to write my query, I would first write the address of the table, which is fantasy characters. Next, I could use the where clause to get those rows where is alive is true. And finally, I could do a simple select star to get all the columns. And here I see that I only get the rows where is alive is equal to true. So where is effectively a tool for filtering table rows. It filters them because it only keeps rows where a certain condition is true and discards all of the other rows. So if you want to visualize how the where filter works, you can see it as a horizontal selection of certain slices of the table, like in this case where I have colored all of the rows in which is alive is true. Now the where statement is not limited to Boolean fields, it's not limited to columns that can only be true or false. We can run the where filter on any column by making a logical statement about it. For example, I could ask to keep all the rows where health number is bigger than 50. This is a logical statement, health bigger than 50, because it is either true or false for every row. And of course, the where filter will only keep those rows where this statement evaluates to true. And if I run this, I can see that in all of my results, health will be bigger than 50. And I can also combine smaller logical statements with each other to make more complex logical statements. For example, I could say that I want all the rows where health is bigger than 50 and is alive is equal to true. Now, all of this becomes one big logical statement, and again, this will be true or false for every row, and we will only keep the rows where it is true. And if I run this, you will see that in the resulting table, the health value is always above 50 and is alive is always true. In the next lecture, we will see in detail how these logical statements work and how we can combine them effectively. But now let us focus on the order of operations and how the where statement fits in there. When it comes to the lexical order, the order in which we write things, it is pretty clear from this example. First you have select, then from, and after from you have the where statement. And you have to respect this order. When it comes to the logical order, you can see that the where clause follows right after the from clause. So it is second actually in the logical order. If you think about it, this makes a lot of sense because the first thing that I need to do is to get the data from where it lives. And then the first thing I want to do after that is that I'm going to drop all the rows that I don't need so that my table becomes actually smaller and easier to deal with. There is no reason why I should carry over rows that I don't actually need, data that I don't actually want, and waste memory and processing power on it, so I want to drop those unneeded rows as soon as possible. And now that you know that where happens at this stage in the logical order, you can avoid many of the pitfalls that happen when you're just learning SQL. Let's see an example. Now take a look at this query. I'm going to the fantasy characters table, and then I'm getting the name and the level. And then I'm defining a new column. This is simply level divided by 10, and I'm calling this level scaled. Now let's say that I wanted to only keep the rows that have at least 3 as level scaled. So I would go here and write a where filter where level scaled bigger than 3. And if I run this, I get an error, unrecognized name. Can you figure out why we get this error? Level scaled is an alias that we assign in the select stage, but the where clause occurs before the select stage, so the where clause has no way to know about this alias. In other words, the where clause is at this point, and our rules say that an operation can only use data produced by operations before it. So the where clause has no way of knowing about the label which is assigned at this stage. So how can we solve this problem right here? The solution is to not use the alias and to instead repeat the logic of the transformation. And this actually works because it turns out that when you write logical statements in the where filter, you can not only reference the columns of the tables, but you can also reference operations on columns. And this way of writing operations on columns and combinations between columns works just as what we have shown in the select part. So that was all you need to know to get started with the where clause, which is a powerful clause that allows us to filter out the rows that we don't need and keep the rows that we need based on logical conditions. Now let's delve a bit deeper into how exactly these logical statements work in SQL. And here is a motivating example for you. This is a selection from the characters table, and we have a where filter, and this where filter is needlessly complicated. And I did this intentionally because by the end of this lecture, you should have no trouble at all interpreting this statement and figuring out for which rows it will be true. And likewise, you will have no problem writing complex statements yourself or deciphering them when you encounter them in the wild. The way that these logical statements work is through something called Boolean algebra, which is an essential theory for working with SQL, but also for working with any other programming language, and is indeed fundamental to the way that computers work. And though the name may sound a bit scary, it is really easy to understand the fundamentals of Boolean algebra. Now, let's look back at so-called normal algebra, meaning the common form that is taught in schools. In this algebra, you have a bunch of elements, which in this case, I'm only showing a few positive numbers, such as 0, 25, 100. You also have operators that act on these elements. For example, the square root symbol, the plus sign, the minus sign, the division sign, or the multiplication sign. And finally, you have operations, right? So in operations, you apply the operators to your elements, and then you get some new elements out of them. So here are two different types of operation. In one case, we take this operator, the square root, and we apply it to a single element. And out of this, we get another element. In the second kind of operation, we use this operator, the plus sign, to actually combine two elements. And again, we get another element in return. Boolean algebra is actually very similar, except that it's simpler in a way because you can only have two elements, either true or false. Those are all the elements that you are working with. And of course, this is why when there's a Boolean field in SQL, it is a column that can only have these two values, which are true and false. Now, just like normal algebra, Boolean algebra has several operators that we can use to transform the elements. And for now, we will only focus on the three most important ones, which are not, and or. And finally, in Boolean algebra, we also have operations. And in operations, we combine operators and elements and get back elements. Now we need to understand how these operators work. So let us start with the not operator. To figure out how a Boolean operator works, we have to look at something that's called a truth table. So let me look up the truth table for the not operator, and in this Wikipedia article, this is available here at logical negation. Now, first of all, we see that logical negation is an operation on one logical value. What does this mean? It means that the not operator works on a single element, such as not true or not false. And this is similar